recording. Okay, go back to Simpson 1/3 rule. Okay, and we use Simpson 1/3 rule to estimate the integral fx dx from a to b. Okay, the integral fx dx from a to b is actually can represent the area. Okay, the area below the curve y equal to fx. And using Simpson 1/3 rule, minimum we must have two segments. Mean you divide the area into two sections, what we call segment. You have here one segment, second segment, and the integral limit from a to b, where a to b where we denote the x naught equal to a, x1. Because you got two segment, you have three data point, x naught, x1, x2. x2 is actually equal to b. x2 is equal to b here. And by using Simpson 1/3 rule, is approximate by the formula h/3, where the h is actually the interval, which is x1 minus x0 or x2 minus x1. You have the consistent h. So the integral fx dx from a to b using Simpson 1/3 rule is equal to h/3 f0 plus 4. This one we can simplify as h3 fx0 simplify as f0, f bracket x1 f as a f1, fx2 as a f2. Mean this is f0, this is f1, this is f2. So Simpson 1/3 minimum must be two segment. And of course if you estimate using two segment, there will be errors there. Where's my there's a down key. Yeah. Mean actually how they obtain this formula is actually I think through the some formulation using the Lagrange technique to obtain two segments, 3 point, you have a quadratic or parabola curve. This is a parabola curve, and then and you see that the area is actually estimated below the blue curve, below the blue curve. So this part, the white part, this one should be included in the calculation, but is excluded. This part not included. This part, suppose not included, is included. That's why the error is big if we use only two segment. If compare trapezoid is only one segment, and totally is if trapezoid totally they connect through this one. This is a straight line, and then using the area of trapezoid will be a is actually h/2 f0. If trapezoid this is f0, this one will be f1 because one segment, so you have only two data point, so h/2 f0 plus f1 like this. This is if you're using trapezoidal rule for one segment. Simpson 1/3, if you use one segment, the error is even bigger because trapezoid is a linear approximation because estimate using the linear graph, and Simpson is actually estimate using the parabola quadratic, which is higher order. So Simpson 1/3 is always better or always more accurate than trapezoid, trapezoidal rule. So this is for two segment for Simpson 1/3. Trapezoid minimum is one segment. Simpson 1/3 minimum is two segment. And then to get a better approximation or better result, we'll increase the number of segments. So here A1, this is a basic structure for Simpson 1/3. You must have two segments, A1 and then A2 until AN. So where the A is actually equal to x0, and then x1, x2, x3, x4, xn minus 2, xn minus 1 until xn. And then this is we want to do the integration of fx dx from A, which is equal to x naught until B equal to xn. Okay, by approximating the area below the area using the segment A1 consists of two segments, mean the A2 two segment until AN, and each area there you use this basic formula, which is H over 3 F naught plus 4F1 plus F2. Okay, means here. So for A1 is actually x naught, x1, x2. You see, the graph here, x naught, x1, x2, and is estimate using the basic formula H over 3 F naught plus 4F1 plus F2. And then for area 2, you notice area 2 start from x, the data point is x2, x3, x4. So using the basic Simpson 1/3 rule formula, H over 3 for area 2, H over 3. So starting point is here, number 2, so F2, and then the ending point is F4 one time. The middle F is actually 4 times. So when you concentrate on area A1, you see area A1 x naught, x1, x2. And then the integral is estimate using H over 3. That's why Simpson 1/3 F naught. The starting F 1 time, middle F 4 time, ending F 1 time. So for A2, where the data point consists of x2, x3, x4, so again H over 3 F2 1 time, F3 middle, middle F, the intermediate F 4 time, F4 1 time. Until the last segment AN, where consists of the point xn minus 2, xn minus 1, xn. Hence, it estimate using the basics formula as H over 3 Fn minus 2, 4 times Fn minus 1 plus Fn. And then later on, you factor out H over 3 for each term. So that's why the formula is this is what we call composite Simpson 1/3 rule. Mean we take more than 2 segments, and n must be 2m. So mean n will be a even number, because from 2 you can duplicate 4, 6, 8, 10, always even number. Mean 2 times of the m is a integer number. And you notice starting starting of the f mean f naught 1 time, Fn 1 time. Yeah. This one later on we put F naught plus Fn in the first column, and you notice 4 F1, 4 times F1, 4 times F3. If you do the A3, later on you have a 4 times F5 and so on. Here the last segment, 4 Fn minus 1. So you notice 4 times Fi, where the I is actually odd. Mean the odd number, the odd F multiplied by 4 times. And then F2 here, F2 and F2 2 times. If you do A3, segment A, mean area A3, you should have H over 3 4. So this is F4 plus 4 times F5 plus F6. Erase everything. F2, this is F4, and then you have H over 3 F4 plus 4. Why so erase? Not 4. Here. Where is the for section A3, H over 3, here is F4 plus 4 times F5 plus F6, and so on. So you see F2, even F 2 times, F4 here 2 times, F6, if later on here you got another one, A4, then you have H over 3, this is F6 plus 4 times F7 plus F8. So you notice odd F is multiplied by 4 times, all the even F are multiplied by 2 times. So this is the Simpson 1/3 rule formula. Okay, and example 6.2 here, approximate the integral exponent negative x squared dx from 0.2 to 1 by Simpson 1/3 rule with n equal to 8. So given n, you can find h. H is actually given by b minus a over n. If given h, then you can find back n. This one given n, then you can find h. If given h, then you can find n. So b is actually upper limit, which is 1. A is lower limit, so mean 1 minus 0.2. You have 0.8 divided by n is 8, so you get 0.1. So the h is help you to tabulate the function here. Means from 0.2 increase by 0.1. So 0.2, 0.3, 0.4, 0.5, 0.6 up to 1. Total you have 8 segments there. And then you can use a calculator to tabulate the functions quickly by just plug in the starting value, ending value, and the step side. Where's my calculator? Here. Okay. How to find back the calculator? Okay, you go to the table, table menu. Okay, here only I have only one screen. I cannot view. If I put it this one, I cannot see the calculator. Because here I have only one screen. So I can only view it here. So the fx is exponent negative x squared. Where the x squared? Okay, gx, I just want one function, so gx I let it 0. Starting is a lower limit, which is 0.2. Okay, ending, which is upper limit, which is 1. Step side is actually 0.1. Step is actually the h, 0.1. Okay, so the calculator help you to tabulate from 0.2 with increment 0.1 up to 1. Then you just need to move it to the Simpson 1/3 table like this. Okay, Simpson 1/3 formula, 1/3 rule formula. The formula is the integral is approximately equal to h over 3. H in this case is 0.1 over 3. So divide by 3. F0 plus Fn is actually the first column of the sum. Means from the calculator, from the f function that you obtain from the calculator, you break it into 3 columns. First column is actually F0. Okay, how you know note? From the 0 here. Okay, the calculator start the row number from 1. Okay, so we end up with 9. Okay, for numerical, we start with 0. So, 0 indicate the row number. Okay, if n equal to 8, n equal to x, hence, n equal to x, hence, your I will stop at 8. I will stop with 8. H is actually 0.1. So, from 0.2, 0.3, 0.4, 0.5 up to 1. Okay, then you need to move the table of fx value to its corresponding column here. First column is a f0, the last column is a fn. Okay, and 4 times of odd f. Okay, so you may move all the middle one to the second column first, and then the odd refer to the I here. So this is f1, this is f3, f5, f7. This is f2, f4, f6, even f. f8 even is even number, but is at the ending f. So you move to the first column. So later on, you just sum it. Sum 1, sum 2 mean you add up. Okay, here, this one you add up, then you add up. So you have sum 1, sum 2, sum 3. Then just plug in into the formula. F naught plus KH 0.3 divided by 3. F naught plus Fn is here 1.3287 plus 4 times summation 2 sum 2 is 2.7502 plus 2 times sum the third sum which is 2.0771. Calculate in one step using your scientific calculator. You obtain this value. Yeah. Okay, and then you can also use the scientific calculator. Before that, in mode number 1, you can click calculate in one step 0.3 divide by 3. Okay, the first sum is 0.3679 plus 4 times 2.7502 plus 2 times 2.0771. So I get here, I think I must key in wrongly. 2.0771 0.3. The first sum is 1.3287. 1.3287. Okay, 4 times 2.7502. So you get 0. This one, this is 95. Typo. 0.9, 5495. This one. And then you can also use a scientific calculator to get the exact solution. Okay, so the integral exponent negative x squared. Ask the calculator to help you to integrate directly. Okay, the calculator can perform the finite integral only, meaning you must have the limit. Otherwise, it cannot give you the the integrand mean the result of the integral in term of function. Must be provided the limit only. So you get 0.5495. Hence the absolute error. Okay, 0.5495, 0.5495. So it's 0. The absolute error is 0 at 4 decimal place calculation. Okay, do you have any questions here? This is using manual, using calculator and paper. What happened? Hanging. How do we? Where's the mouse? Okay, later I'm going to show you if you want to perform it using Excel. Then the same thing, you just need to do all the table in Excel. You have an I column indicate the row number X, and then the F. I cannot increase. Okay. So given you have the A is a lower limit which is 0.2. I'm sorry. A here is 0.2. b is upper limit, which is 1, and given n is 8, then you need to calculate the h. H is actually b minus a divided by n. So you get h is 0.1. Then the I 0, 1. If n is 8, then the I will end with 8. So you drag it until you obtain 8. Okay, let me center it. Put the grids. Okay. F we got 3 column. Okay, X is actually this cell is X naught. X naught is actually start with X naught. I can equal to A. Okay, I can make it as a constant so that later on when I copy it, okay, it won't run. Okay. So this is X naught. X1 is actually X1 is equal to X naught plus H. Okay, H, okay, I make it as constant so that when I copy it down, the H won't run. So, and then you can drag down. So you end up with upper limit is 1. So you notice, okay, if you not put dollar front and back, when you copy it down, this cell will move down accordingly. So you want to always refer to the same cell, make it constant. Okay. And then now calculate the F naught. F naught, the function is actually exponent, so exp negative. Okay, so this is x, and then minus x squared. Okay, luckily this one is, okay, luckily all the x is positive. If your x consists of negative, so negative you square it, negative, later positive. So, but luckily x is positive, then this one you still can get negative. Okay, no problem. Okay, then you can drag down. Okay, this one I without rounding anything. So we can just drag down to tabulate, okay, a table of the function value. And then later on, I move the intermediate, not including the F naught and F8 to second column. Then F1, and then the second one, this one move to the third column. Okay, and then you can sum it quickly using the auto sum, okay, icon. Okay, you click, you see they only sum this one because this is empty. Hence, okay, you click at the border, you see double-headed arrow. Click, drag it. Click, hold down to drag it. Okay, so now you include sum from F naught to F number 8. Okay, now you can point to the sum one at the right bottom. You get little plus. Click, hold down your mouse, drag it. Okay, you see. It follow. Okay, so when you copy it, okay, the formula initially is in C. Okay, C. We sum this column. So when you copy it to the next column, the pattern is followed. Okay, so the same thing you copy it. So this is raw data without rounding anything. Hence, the answer for your integral is actually now you plug in into the Simpson 1/3 formula. Simpson 1/3 formula. Okay, so we plug in H, which is this one, H. Okay, you can make it constant so that if you when you copy it to the next table, it won't run. H divide by 3. Okay, multiply is a asterisk, and then open the bracket. First sum here plus 4 times odd F plus 2 times even F. So you get 1.22599. Some sort like not correct. Let me check. 0.5485. Okay, I'm checking. Exponent negative x squared. Oh, I know. Okay, you see the value y different. Exponent negative x, which is b9 squared. Okay, let me see, is it this one? Okay, the value different because okay, if I don't, okay, negative x squared here, to key in into Excel, you have to key in this one, negative exp. Okay, the x here, make sure you bracket. Okay, this one, my x node is b9. So you see this one. So you take b9 squared first, later on multiply with negative. So the, okay, you still carry the negative. If you don't put the bracket, initially you see I put like this, negative b9 squared. So you take negative b9 together and then you square it. So no more negative. That's why the, okay, all the function there is run. Okay, so now, okay, so you recopy it again, remove again. Okay. So 5494. Okay. So now, okay, after we edit back the formula here, exponent bracket negative, and then the b9 must bracket, so that when you, okay, you will square first, later on still carry the negative sign. So now we get, okay, 0. Okay, this one I didn't round anything, so I round at the last step 0.54 5495. 5495 also tally with, okay, what you do, okay, in, okay, using calculator, and on paper this is round to 4 decimal place, starting from you tabulating okay, value of f. But in Excel here I didn't round anything. Okay, if you want to round also can. So from this step you just round it. If I round it, then I have to do it again. If I round it, so now it's 4, okay, 4 decimal place. So recopy it again. Okay, of course, without rounding one is, okay, more accurate, because it take up more decimal place. So, but to compare with what you done, okay, using, okay, calculator, rounding to 4 decimal place. So okay, so now you get, okay, comparable, okay, result with, okay, 4 decimal place calculation. So 0.5495. Okay, this is the first example for Simpson 1/3. Okay, if you any question that you want to ask, okay? Okay, if not, okay, we move to the next example. So approximates, okay, this one approximates the integral x over square root 1 plus exponent x dx from negative 1 to 2 by Simpson 1/3 rule with h equal to 0.25. Now given h, then you can find n. So n will be b minus a over h. Okay, in the formula, okay, or h is b minus a divide n. So given n, you find h. Given h, you find n. So b is upper limit. So 2 minus lower limit. 2 minus negative 1, you have 3. So 3 divide by, 3 divide by 0.25 is 1/4. So is 12. So you have here n equal to 12. Okay. So I will stop at 12 here. And then from lower limit negative 1, you plus with 0.25. You get negative 0.75 plus with 0.25 and so on. And you can quickly tabulate this one using the table menu. Those who own the MS calculator, you have no choice to calculate using the calc menu there. Calculate one by one. Those you don't have the ES onward, then you have to calculate one by one. Because the MS model, you don't have the table menu there. This is table 9. So now you can use alpha x divide. So go down. Square root 1 plus exponent x. Alpha x. Alpha x. Gx. We don't have the second function. We key in 0. Starting is a lower limit, which is negative 1. Ending is upper limit, which is 2. Step side given in the question is 0.25. Then you can get this. When you want to copy down the value, make sure you read at the bottom. The bottom one, negative 0.855. Then negative 0.6181 move to second column. And then negative 0.3439. Don't read at the top. Top only show you 3 decimal place. Read at the bottom. Negative 0.3945. So you put into the correct table of Simpson wanted rule. Find their sum 1, sum 2, sum 3. Plug in into the formula, you'll get this one. And you can check using the scientific calculator, the integral button of your scientific calculator. And we see against the absolute error in this case is 0 when you use 4 decimal place calculations. Do you have any question want to ask? Are you all still around or not? Any questions?
No, doctor.
No, doctor.
If no, we can see as the next example, this one using trapezoidal and Simpson wanted. So you see the question for here, we can just change the functions. The function to be integrate lower limit, upper limit. Either give you the n or h. So in this case, n equal to 6. So to use Simpson wanted, this one is here. Simpson wanted, n must be even number. So this case, n is 6, so you can use Simpson wanted. Sometimes the question, let's say they give you n equal to 7. Ask you to solve it using appropriate method. If n equal to 7. So this is an odd number. Hence, you cannot solve it using trapezoidal rule. You can only solve it using n equal to 7. You cannot solve using Simpson wanted. You can only solve using trapezoidal rule. So for both case technique, first of all, given n, you find the h. You have 5 minus 2 divide 6. So 3 divide 6. So you get 0.5. 0.5. And then the same step, tabulate the function. So you tabulate h is point. This one is given what? Oh God. Okay, given n, so you find the h. H is okay. I think this one typo. This is 2.5. 2.5. So x from 2 mean given n equal to 6. So I, you see n with 6. So h is actually 5 minus 2 divided by 6. 3 divided by 6 is 0.5. So 2, okay, this is 2.5. 3, 3.5, 4, 4.5, 5. Okay, and then you tabulate it using the, okay, using the, okay, this one, can AC, okay, key in the new function now is 2 plus sin, okay, square root 2 x. Okay, starting, okay, is 2, ending is 5, step side is 0.5. Okay, so when x2 2.9092, okay, 2.5, 2.7867, okay, and so on. Okay, for trapezoid, the first column are same with Simpson 1/3. Only second column, okay, trapezoidal rule, only 2 column. Okay, F naught, Fn. Okay, the first sum. Okay, other F in second column. So you can see trapezoidal rule. Compare Simpson 1/3. Simpson 1/3. Okay, to do Simpson 1/3, okay, if you use Excel, okay, you drag it until you get the F6, and then you select F1 to F5, move to second column. You sum this one, you sum this one, plug into the, okay, trapezoidal rule. Okay, this is for composite trapezoidal rule. Basics actually h over 2 f naught plus f1 if one segment. If more than one segment, okay, so it become 2 times the f in, okay, the intermediate f, middle f is 2 times. So you have here f naught plus fn is 4.8885 plus 2 times the second sum here. Then you get this result. Okay, and then Simpson 1/3. You see, okay, second column is odd f, third column is an even f. 6, okay, is the last, okay, value of f, so move to first column. So plug into the formula. F naught plus Fn is the first sum, 4.8885. The second sum is here, 4, okay, 4 times 7.4035, and the third sum here, okay, 2 times. So you get this one. The result is 7.3991. Okay, and you can check, okay, with the exact solution by your calculator. Menu number 1, integrate what? 2 plus, make sure you are in radian mode because you have the sin. 2 plus sin, okay, square root 2 alpha x. Okay, I close the sin, I close for the whole, okay, function, and then 2, 2, 3. Am I right? 7824. Oh, no wonder. 2 to 5. I key in 2 to 3. Yeah, this is 2. This is 5. Okay, 7.3993. Okay, the exact is 7.3993. Exact is 7.3993. So the absolute error for Simpson 1/3 is smaller with 0.0002. Okay, compared to the absolute error using trapezoidal rule is, okay, 0.0006 because 69, no, greater than that. Erase it. Yeah. Okay. Where is it? Yo. Hanging. this is wrongly calculated, not 0.06, but greater than this, 7.3969. How to get it? Yo, how to make it smaller? Escape. Here. Okay, I want to erase this one. Okay. Okay. 7.3993 minus 7.3969. Okay, the error is 0.0024. So as I said, trapezoidal rule is linear approximation. Simpson 1/3 is quadratic, so Simpson 1/3 rule is always more accurate compared to trapezoidal rule. You see the error is smaller compared to trapezoidal rule. I think this is the O. This one is the O far. Okay, and then we perform one more this one for you to see it. Compare the Simpson 1/3 and Simpson and trapezoidal rule. Here, so I can here move or copy, create a copy. Where's my delete? Okay. So for this example, using Excel here, A you change it. A is 2, B is 5. Okay, but this is given. This question is given n. N is 6. Then you change n. H is 0.5. So this is template. I just if this one is given n, then you calculate H. Okay, and then now 2.5. 2 until 5. Okay, so these two extra you delete it. Okay, now you change the functions. Okay, the function is 2 plus sin sin. Okay, and then square root is sqrt. 2 multiply, make sure asterisk. Okay, and then the x, click the location of x node, close it, close for square root, close for sin. Okay, enter. Okay, so copy it down until F6. Okay, and then okay, so I will do the trapezoidal rule first. Trapezoidal rule just 2 column. Okay, and the sum is actually h over 2 times. Something wrong. h over 2 cx2 dx. Why the answer so big? Okay, this one 7.3969 in Excel, 7.3971. Okay, because I didn't round it. Okay, to check with the manual using 4 decimal place, then you need to round it. Otherwise, it will run a bit because okay, the Excel without rounding is actually more accurate. So 7.3971. Still a little bit different. Okay, even though I round, still a little bit different. Never mind. Then okay, so this is a trapezoidal rule. Then for Simpson 1/3, you can copy this table including the formula here. Control C, select, okay, and then Control C, and then you can paste it. This one, delete. I paste it here. Okay, this becomes Simpson 1/3. Yeah, Simpson 1/3. Okay, and then for Simpson 1/3, the even F move to the third column. Okay. So the answer wrong because I added accordingly to the Simpson 1/3 formula, h over 3 times first sum, and then second sum is 4 times, in the odd f 4 times. Okay, the last sum, which is a even f 2 times, this one, okay, and 7.3993. Okay, 3993. So okay, exact 7.3993. So you see, perform using the Excel, I think is more accurate, even though I round it to 4 decimal place. Because it may let's see, compare the Simpson 1/3, see where is a different. Because here when it run a bit, 6382, this is 6381, 3081. So it run a bit, okay. And then here the last answer provided by Excel is 7.3993. Yeah, this is using calculator 7.3991. Okay, so okay, a little bit different. I think this one also because the same thing, run a bit, okay. That's why here in Excel you get 7. Okay, the last answer 7.3971, and okay, in calculator is 7.3969, even though I round it to 4 decimal place. Okay, from the Simpson 1/3, you can see that Excel is still perform better even though I round it, okay, to 4 decimal place. So this is about the Simpson 1/3, and just quick go through the trapezoidal rule. Okay, to get better understanding of trapezoidal rule, you can watch back, okay, the YouTube, okay, as given yesterday. Okay, so do you have any question that you want to ask?